E and natural logarithms. So you guys have seen ln before, and I've mentioned it before, but we've never actually solved the problem using natural logs. So we're going to do that today. All right, so it says in section 10.1, we talked about using the formula a of t equals p times 1 plus r to be t. And this was what we used when we were determining interest. Okay, but that's not how real life works. So if I invest money in a bank, what it will say is something like, you don't have to write this, but like 3% interest compounded monthly. Okay, and it sounds good. It's like, oh, so if I invest $100, then at the end of the month, I'm going to have $103? And that's not how it works at all. Okay, when it says 3% compounded monthly, what they do is they take the 3% and they divide it into 12 pieces. Okay, because you're going to go every single month, and then they give you that 3% spread out over 12 months, kind of. Does that kind of make sense? And then what you raise it to is the total number of times you're going to compound. So after 1 month, you would compound once. After 2 months, it'd be compounded twice. So let's think about it. If I put it in for 4 years, and I'm compounding monthly, how many times will I compound my interest? What is 4 times 12? Yes, it's 48. Agreed. So you would find what that is. So you'd have whatever your initial amount was. So let's say I had $100 originally, and I'd multiply by that. That would be my setup. Okay. So this is the new formula. So it's a of t equals p times 1 plus r over n raised to the nt. So r is your interest rate, but that r is being divided by n, the number of compounds per year. Okay. And then what we raise it to is nt. So this is the total number of times we compounded. So the number of years, which is t, times the number of times compounded, like monthly would be 12, quarterly would be 4, and so on. You need to memorize this formula. It looks overwhelming at first, but we're going to do it a lot today. It will be fine. Okay, so number 1, so it says determine the amount that a $10,000 investment is worth in 4 years if it has an interest rate of 8% and is compounded. So we have A, monthly or annually, B, quarterly, C, monthly, and D, daily. So we're going to find each of these. So we're going to do the formula 4 different times. Okay, so the first one, I'm going to have a of t equals, I'll write my formula down, 1 plus r over n, raised to the nt. So I'm finding my amount after 4 years, right? T is equal to 4. I have P is going to be $10,000. And my rate is going to be 0.08 divided by annually, so it's only 1 time a year, raised to the 1 times T. So 1 times 4. 1 times 4, right? I wrote it. Okay. So what I would do is I would always find what this 1 times 4 is. Obviously, you guys know what 1 times 4 is. It's 4. You can do that easily. But when we get to 365, it's a little bit harder to do 365 times 4. So I'd always find what this number is first. If you don't find what that number is first, make sure you're putting it in parentheses when you're putting this all into your calculator. So this is why I said I wanted your calculators out, because I want to make sure that you put this in correctly. Okay, so I'm putting it all into my calculator. And when I do this all at once, I get my amount after 4 years. Remember, that's a function. A of 4 is $13,604.89. Did you all get that? No one got like $18 trillion, right? Please be my banker if you had $18 trillion. No one's, everybody has 13,000 something. Good. All right, and I kept that all in my calculator all at once. This is very precise. So quarterly, if I do A of t equals P, so let me plug in T. T was 4 still. The amount after 4 years equals P, which was 10,000, times 1 plus R is 0.08, divided by N. What's my N now? What do you think if you hear quarterly? What would you guess? No. 4. No, it's every 3 months. I see what you're thinking. But quarterly would be 4 times a year. So a lot of businesses send out their quarterly statements, their quarterly portfolios, and so on. Quarterly means every 3 months, so 4 times a year. So you're going to raise it to the 4 times 4. So I'm going to write my multiplication sign not as a dot, so it doesn't look like 4.4. So 4 times 4. So I'm going to do it again. So I'm going to have my 10,000 times 1 plus 0.08 divided by 4. And I'm going to raise it to the 4 times 4, which is 16. So do you see how my 8% was actually reduced down? And I'm really only getting 2% each time it's compounded. Right? I divided by 4. So my amount after 4 years is equal to $13,727.86. Good? Yeah. A little bit more than the last one, about 120 something dollars more. That's pretty good. So how about this next one? What if we go even more? Do you think we're going to raise by a lot again? Probably. Let's try it. So I have my amount after 12 months, or my amount after 4 years. But I'm using n equals 12 now, monthly. Maybe I should write what my n's are for each one for your notes. So I have a of 4 equals 10,000, 1 plus 0.08 divided by 12, raised to the 12 times 4. So that's my 48. Anybody got it? 13,000. No one's confident? Yep, exactly. Good. So this one didn't increase as much. It didn't go up by $120 again. It's just a little bit, right? Okay, so what if we did daily, though? Okay, I would think if I do daily, 365. Don't be smart, Alex, too, and be like, 365.25, there's a leap year. Like, I don't care. We're going to do 365. We'll be consistent. Or some of you guys even know, like, we don't count a leap year on the centuries. Do you guys know that? So, like 365.25 or 24, I can't remember. All right, so we're not doing that. We're just doing 365 days in a year. So we're going to do the amount after 4 years is going to be 10,000. 1 plus 0.08 divided by 365 raised to the 365 times 4. I'll do my multiplication sign again. Anybody got it? Still kind of around what it was before, 13,000. You guys aren't very fast with your calculators. Do you guys have this? Did you get that? 13,770.79. Yeah? So it didn't go up very much, did it? Like $14. Not much. Okay, so it appears that there seems to be a little bit of a limit to the growth. Do you guys know what I mean by that? So it's getting bigger, but it's not going to go up to infinity. Okay, yeah. So yeah, it kind of has like a horizontal asymptote. It's growing, but it's kind of tapering off towards some value. So it ends up being kind of like a horizontal asymptote. Great. Yes? What if we do it every second? What if we did every second? Do you think, would it go to infinity? It wouldn't. So it's kind of weird. So that's what this little chart is on the next page. Oh, we put your phone away. So it says if we kept going, one would think that this $10,000 investment would grow really, really large. This always makes me think of Office Space. I don't know if you've seen this ancient movie because I'm old. Yeah. Yeah. Most of you guys haven't seen this movie. So this movie was like back in the 90s. I don't know. And it was very popular. It was a really funny movie. You should watch it. But basically, they decided they were going to rip off their company, and every single penny they were going to round a little bit, and they were going to steal from their company and put it into a bank account, but they messed up a decimal point, and they compounded continuously. And after a day, they just had thousands and thousands of dollars. And they're like, what do I do with this? How my company's going to know that I just stole $1,000 from them. So it's a pretty funny movie. So first they messed up the decimal point, but if you're compounding continuously, one would think that, yeah, your money would grow really, really fast. But it doesn't, because there's a limit to it. So let's figure it out. So let's say we have $1. That's our P. Our annual rate is huge, not 8% anymore, but we're making it 100%. Okay? And we're going to have it for 1 year. So T equals 1. I didn't say that in there. Then in my formula, my A of T equals P times 1 plus R over N raised to the NT. Most of this stuff is 1. So the P was 1, the R was 1, right? 100% is 1. The T was 1, and it ends up giving you this formula. A equals 1 plus 1 over N raised to the N. So if we just compounded 1 time a year, annually, then after 1 year, we would have 1 plus 1 over 1 raised to the 1. We'd have $2. Does that make sense? 100% is my rate. So after 1 full year, I have 100% added to what I had before. So instead of having $1, I've now doubled it. I have $2. All right, quarterly. This means I have 1 plus 1 over 4 raised to the 4. So I find it. I do 1.25 raised to the 4. I'll round to 4 decimal places. So I get 2.4414. So this means if I started with $1 in a year, if I compound quarterly, I have $2.44. Okay, so more than double. All right, monthly, same thing. 1 plus 1 over 12 raised to the 12. So we find it. I get $2.61. So I'm going to do 2.6130. All right, so let's go with this side of the room. So from Libby and Yaya over, you guys are going to do the next one. So you're going to do daily, so 365, and then you guys are going to do 525,600 minutes. You guys know that long. It'll be in your head the rest of the day, won't it? It's from Wrench. Okay, and then give me the answer to 2 decimal places once you have it. So how about the 365ers? What'd you guys get? 2.71. Do 4 decimal places. 4. Yep, good. All right, and then the 525,600 minutes. Huh? Did you get 0? Yeah. I don't know what you did.
Now we're at 2.71. Sorry, 2.72.
2.7, 4 decimal places.
2.718.
Yes, 2.7183. Correct. All right, that's what it goes towards. It gets closer to like $2.72 around there. And this number is very important. This number is called the natural base because it occurs so often in nature. And this number is E. So right here I have what E is. It's 2.718281828. And you're like, oh, it just repeats. 281828. It does not repeat. Okay, this is an irrational number just like pi. It goes on forever. Yes? Is it the same thing that you use in what? Yes. So E is a number. Yes. It's very exciting. Actually, it's not. E is, I think it's capital E there. But we do use it a lot in nature. All right. So anyway, C is the speed of light. That's used in that formula. Do you know that we have all these things? This is why in algebra, why we always use X. Because a lot of these other variables have numbers associated with it. So you guys have learned pi. Pi is a number. It's Greek. Or pi is a letter, right? It's a Greek letter. But we have I. We've learned that. We now have E. C is the speed of light. A lot of these letters are actually numbers. Well, there's lots of them. Omega. All right, so let's see. So when things are commented continuously, we use the following formula. So whenever you see commented continuously, you have A equals PE to the RT, PERT. So when I was in school, we always remembered PERT Plus. PERT Plus was the type of shampoo that was very popular in that time. It is no longer popular. No one uses it. Have you ever heard of it? You use PERT Plus? I know. My husband is still one of the sole people that uses PERT Plus. Sorry, YouTube viewers, if you use PERT Plus. But yeah, so you guys don't know that. So you just have to remember PERT. A equals PE to the RT. It smells like menthol? Is that what it's called? Like the Vicks Vapor Rub? That's what it smells like. It's supposed to wake you up in the morning. All right, so if the rate is positive, something's growing. If the rate is negative, then it's decaying. So we're going to use this for things like carbon-14 dating, right? Yeah. Okay, so logarithms, natural log has the same properties as logarithms. When you see ln, it's read natural log, which people don't like because they're like, wait, that's backwards, ln. Shouldn't it be nl, natural log? But logarithms are French. Doesn't the word logarithm sound French? Yeah, so it was like logarithm natural. I'm not going to say it with a pretty French accent. Do you know what I'm saying? So a lot of times additives are after in French. So ln. And what an ln is, it's just log base e, because e is called the natural base. So natural log. I don't know why they don't just write log base e. It saves you half a second in writing ln versus log base e. And it confuses Algebra 2 students worldwide. Like, why do we do that? I don't know. So if you see an ln, and you get confused at what that means, think of it like this. ln is just log base e. And if I have log base e of e to the 0.15t, well, what did we do when we did log base 2 of 2 to the 5? What did it end up being? It was 5. Remember, powers you can bring to the front. You have log base 2 of 2. And on that, we say 2 raised to what power gives you 2? 1, right? So all of this became 1. We're doing exactly the same thing here. So my 0.15t goes to the front. And the log base e and e cancel each other out. It's 1. So we get this as our answer. Well, we also had a rule that if we had like 10 to the log base 10 of 2, what did it become? You should know this right away. Let's be in the non-calculator portion. It became 2. Do you remember that? Or 7 to the log base 7 of 8 is 8. Do you remember that rule? Do you need me to write it in logarithmic form so you see it? So what if I switch this? This is an exponential form. If I switch to logarithmic form, it looks like log base 7 of 8 equals log base 7 of 8. So remember the little swoopity-doo thing? 7 to the log base 7 of 8 equals 8. Does that make sense? Do you see it when it's written in the log form? Log base 7 of 8 equals log base 7 of 8. That's true, right? So that's why this works out. It's a little quick proof of why it's true. Okay, so if we have e to the log base e of 5, we could just cancel the e in the log base e. But we don't have that. We have e to the 3 times natural log of x plus 1. We don't have e and natural log right next to each other. So what can we do? Any ideas? I can not get rid of the 3, but I can put the 3 in another location. Nope, it can't go in front. It's already in front of the logarithm. It's going to go up as a power. It's going to go up here. So it's going to be e to the natural log of x plus 1 raised to the 3. Does that make sense? It can only go in front of a logarithm. It was already in front of the logarithm. So now the e and the natural log cancel. So I get x plus 1 to the 3. That's your answer. Okay, number 3 is a quick one. Natural log of e to the 2x. What's that? Close. 2x. What about natural log of e to the x? X. 2x plus x is 3x. That's your answer. So what about a second way of doing this? What do we do when we have 2 separate logarithms? So 2 logarithms separated by a plus sign. How can I combine them into one logarithm? Yep, so it's going to be ln. So it's going to be natural log of e to the 2x times e to the x. So if I had x squared times x to the 5th, I would add my powers, right, Hazel? So if I have e to the 2x times e to the x, I'm going to add my powers. I get e to the 3x. And then the natural log and e cancel, and I'm left with 3x. So you could also have done it that way. Seems a little bit harder to me, right? All that adding the powers and stuff. It's much easier the first way. Okay, so whenever you see something and you're reading through and it says continuously. So it says Brian invests $500 at a 5.25% interest compounded continuously. Underline it. That is when you always use the PERT formula. If it did not say continuously and instead it said monthly, daily, quarterly, that's when you use the other formula, the P times 1 plus R over N raised to the NT. So it says, how much does Brian have after 40 years? So I'm going to have my amount after 40 years equals 500 e to the 0.0525 times 40. Notice how I put my RT in parentheses. You want to make sure you do that when you put it into your calculator, because otherwise it's going to raise it to the 0.0525. It's going to take that answer, and then it will multiply by 40. So you want to put it all in parentheses. So try it along with me on your calculator. Make sure you have the same thing. The biggest mistakes on this test are calculator errors. So after 40 years, he gets $4,083.08. So it seems like a big jump, right? He went from $500 to $4,000. But it was over 40 years, so it seems reasonable. If it was like in a year he made that much money, then we have a problem. Okay, so let's solve these equations. So the first one, so I have a to the 3x minus 4 equals 10. Okay, so we're going to add 4 to both sides. So I have e to the 3x equals 14. How do I get rid of my e? Yeah, I'm going to use a special kind of log, though. The natural log, right? You could just do a log, like just regular log, but then you would have to do, like if you had log of e to the 3x equals log of 14, you would pull it to the front, you divide by log of e. I mean, it would work, it's just messier. In this case, when you do natural log of both sides, natural log and e go away, right? It becomes 1. The 3x gets pulled to the front. So I have 3x equals natural log of 14. So I find natural log of 14. Do you guys see the natural log button on your calculator? Yeah, ln. Sorry, I didn't mention e to the x is right above it, right? So you do second ln. Did you guys have trouble finding that on your calculator? There's also another e button over here on the right-hand side, but it doesn't have raised to anything. Okay, so I do natural log of 14. I divide by 3. So your answer is 0.880 if you round to 3 decimal places. That's what I'll ask for. I'll ask for it rounded to 3 decimal places. Now colleges are going towards not having students use calculators at all. Don't you love that? I know. This is why I've been training you. You have a calculator portion and a non-calculator portion. Colleges are mean because people try to cheat on their calculator and they type in a bunch of stuff. You don't do that. Okay, so what they would have you leave it as in college is natural log of 14 over 3. That's called the exact answer. Okay. But I personally prefer the decimal. It's easier for me to grade than going through and being like, oh, 1/3 of natural log of 14. Yeah, that's good. Or natural log of the cube root of 14. Do you see how you got that? You can bring the 1/3 up as a power. Those are all correct answers. It's frustrating with natural logs and logs. You can have lots of different answers. Okay. Different answers that are the same thing, I guess I should say. All right, so the next one. So B, I'm going to add the 2 over, so I get 36. I'm going to divide by 6, so I get 6. So I have e to the x plus 5 equals 6. Okay, I'm going to take the natural log of both sides. That allows me to pull the x plus 5 to the front, and the natural log of e goes away. So I have x plus 5 equals natural log of 6. I'm going to subtract the 5 over, so I get x equals natural log of 6 minus 5. Natural log of 6 all goes together. You can't say natural log of 1. Right, so I find natural log of 6. I subtract out 5. I get negative 3.208. That's my answer. Okay, those are ones that are in exponential form. There's exponents that have x's. All right, so how about C? This is where students totally freak out because they see natural log. This is what I was saying. Like, why did we do ln? Why can't we just do log base e? So if you are confused, change to log base e. A lot of times if you have natural log and you have no idea where to go, if you just rewrite it in another form, like log base e of 5w minus 2, then you know immediately what you should do. What do I have now? Anybody know what they should do? How about starting here? E to the, no, e to 3 equals 5w minus 2. Remember, you're doing your little e to the 3 equals this part. You're switching to exponential form. So sometimes it's easier when you see it like that. Now, another thing you could do is sometimes, like if you have natural log of 5w minus 2 equals 3, you know that if you had e to the natural log of 4, it's 4, right? You know that cancellation thing. What if you did e to both sides? This cancels, right? So you get 5w minus 2 equals e cubed. Does that make sense? That's what you had right here. So it's the same thing. So you could do that as well. It's just kind of a little shortcut, like e to both sides. Okay, so let's continue to solve. So e to the 3 is a number. We need to find it. So on your calculator, do you guys see the e button? It's where natural log is. So you're going to do second e raised to the 3. So that's going to be like 20.086. And we don't round early. We keep that number in our calculator. Yeah? Okay, what is it? Yep, you're, give me 3 decimals though. Yep, 4.417, that's correct. See, I do this because AP Calc, you need 3 decimals. I have to train you early. So when you take AP Calc, you know it. All right, so 4.417 is the correct answer. Did you guys all get that? So keep the numbers in your calculator. You're going to add 2, divide by 5. All right, so try D. I'll give you a second to try D. I'll pass that out your homework while you're working. All right, here we go. All right, so a couple of you guys said 181. I don't know if all of you guys said 181 something. So let's see. So we're going to add the 3 over. So we're going to have 2 natural log of 6y plus 7 equals 14. We divide by 2. So natural log of 6y plus 7 equals 7. So remember, natural log is just log base e. So if you get confused, you can write it as log base e. So it's like a little e there. So we're going to have e to the 7 equals 6y plus 7. So e to the 7 is a number. We find it. So it's like 1,096 point blah, 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 blah. Right? So I have 1096.633, and I keep that number in my calculator. So I'm going to subtract 7. I'm going to divide by 6. So I get y equals 181.606. So how many of you guys got it perfectly right? Yay. I was hoping more of you, but I'll take that. All right, how many of you guys were so close? Yeah, Jenny was close. She just had a rounding error. All right, so that's how you solve those. Okay, so the last things we're going to talk about are half-life problems. Usually at this point in the school year, I say, oh, have you guys talked about half-life in chemistry? And you've already covered it in chemistry, but chemistry teacher must be a little bit behind because you guys have never done it. That's what they told me all day. All right, so half-life. So half-life is the amount of time it takes for half of a certain substance to decay. This is how we date things like fossils and so on. We use half-lives. Okay, so a useful formula that everyone always forgets, but you can use on your test if you memorize it, is this formula. So R is equal to the natural log of 1/2 divided by the half-life. If you know that formula, it saves you a bunch of steps. Okay, so I'm going to show you what those bunch of steps are on number 1, and then we're gonna shortcut it on number 3. Yeah.
Is half-life like the same thing we talked about when we do like a blood drive? Like they ask, when I take a certain meds and they ask for a half-life.
Yeah, so like, yeah, you use half-lives with medications, like with dosages and things to figure out what your dosing should be. Yeah. I use it for a lot of things. It's kind of interesting. Okay, so plutonium-239 has a half-life of 24,110 years. That's the only thing I want you to find when you start these problems. Okay, Basil, you with me? Yeah. So we're going to start this problem with the half-life. So my half-life is 24,110 years. Okay, that means that I start with a certain substance and I end up with half of what I started with. Because they're up to something, I can tell. Yeah. All right, so if I start out with P, I have 1/2 P after 24,110 years. So half P equals P times e to the r times 24,110. Okay, that's how I set it up. That's what a half-life means. Whatever I start with, I have half of it. Now, do you see when I divide by P on both sides? It doesn't matter what I started with because the P goes away. So I end up getting 1/2 equals e to the 24,110 r. How do I solve for r? I do natural log of 1/2 equals natural log of e to the 24,110 r, which switches it to natural log of 1/2 over 24,110 equals r. So when I divide by 24,110, you're right, it does switch it to log form. Is that what you're saying? Like it's log base e though. Log base e of 1/2 equals 24,110 r. Okay, do you see that's the formula? That was right here. That's what we did. We did natural log of 1/2 divided by our half-life, 24,110, to get our rate. Now everybody needs their calculator out to do this. So pay attention as I tell you the instructions. Are we ready? We're going to do natural log of 1/2 in the parentheses, hit enter, divided by 24,110. When you do that, you get R equals negative 2.87 times 10 to the negative 5. It's in scientific notation on your calculator. Do you guys see how on your calculator it says E raised to whatever? Basil, I'd be trying this on your calculator because your calculator's weird. Okay, you have your own calculator though. Figure out how to do it on yours. All right, so if you guys don't have one of the graphing ones, figure out how to do this on yours. All right, so we have our rate. That is a very annoying rate to have because it's not like just 2 where we can just plug in 2, right? Every single time you use the rate, you'd have to write down that nasty number, negative 2.87 times 10 to the negative 5th. We don't want to do that, right? So what we do is we use the store function on our calculator. Do you guys remember how to do that? So we go down where it says STO, S-T-O, and we hit STO. So it gives me a little answer and an arrow. Do you guys all have that? We want to store it as a letter. Pick any letter you want. You could choose L for Libby or Y for Yaya. I don't care. I usually pick A because it's right underneath alpha. So I do alpha, A. Do you guys see alpha and the math button has a little green A above it or yellow depending on your calculator? Hit enter. We've now stored it as A. I put a little A underneath so I know I've stored it. You got it? Yeah, it's amazing. Now anytime you need that, it's there. You got it. Some of you guys have calculators where you can go up and grab it. Some of you don't though. All right, so now we move on to the second part of the problem. Aren't you guys like, oh my gosh, this problem is so long? It's long because you didn't memorize this formula right here. It makes it much easier. If you know that formula, you're good. All right, so the second part of the problem. It usually gives you specifics about the substance. So it says, how long does it take for 1 gram to decay to 0.1 grams? So we have our A of T equals P times E to the RT. So I have 1 gram for P. I'm decaying to 0.1 grams. My rate is what I've just stored as A, and I have my time. Eat, right? E to the AT. All right, so the only thing that we don't know is T. It looks like E is a variable, but it's not. It's a number. It looks like A is a variable, but it's not. We've stored it. So I do the natural log. I do natural log of 0.1 equals natural log of E to the A times T. So the natural log and E cancel. So I have natural log of 0.1 over A. That is equal to my time. So I do natural log of 0.1. Answer. Okay, and then I divide by A. You end up getting more than 80,000 years. So 80,091.686 years. That's how long it would take to decay to 10% of what it was originally. Okay, does that make sense? All right, sometimes I ask you questions about doubling time. So that's different. Half-life is when something's decaying. Doubling time is when, like, maybe money's growing. How long does it take for your account to double? Okay, that would be like B here. So number 2, it says Kyle has $5,000 in his checking account. Oh, you are rich. You're a very rich high school student, which earns 3.5% interest compounded continuously. What is his total amount after 3 years? When it says continuously, that's your PERT formula. So your amount after 3 years equals P, which was 5,000, E to the R, 0.035, times T, which is 3. I always put that whole exponent in parentheses. You guys kill me. So I have 5,000 E to the 0.035 times 3. So he has $5,553.55. I know, that's a lot of money. So it says, well, how long does it take for him to double his investment? That means we want, if he starts with 5,000, we want how much money? 10,000, right? We want double that. So this time we don't have the time. T is what we're trying to find now. It's a little bit different. Sometimes I like to trick you, and on your test, I don't tell you how much Kyle started with. That means you would put P, and on the left side you put 2P. Does it make sense? Because when you divide out by the P value, when I divide by 5,000, I get 2. That's why it's doubling time. Twice what you had. So I have 2 equals e to the 0.035t. So I'm going to do natural log of 2 equals natural log of e to the 0.035t. I pull this to the front. Natural log and e cancel. So I have natural log of 2 equals 0.035t. And I divide. I end up getting t equals 19.804 years. All right, the very last problem is another half-life one. Okay, so it's talking about a fossil. We're using carbon-14 dating to figure out how old the fossil is. Okay, but we're going to save ourselves some steps this time. It's going to be very quick. And we're going to remember this formula that I had right here. So I'm going to say r is equal to the natural log of 1/2 divided by my half-life. So it's natural log of 1/2 divided by the half-life is 5730. So everybody do that on your calculator. So natural log of 0.5 divided by 5730. You get negative 1.2096 times 10 to the negative 4. You could store this value. All right, now the rest of the question is saying, how long does it take? So he uncovers a fossil that he believes to be a woolly mammoth. He analyzes the fossil and concludes that the specimen contains 15% of what it originally had. So if I start with p, I'm now down to 0.15 p. And my rate is what I've stored. So the key to this problem is realizing that the p's don't matter. When you divide out, it goes away. So you have 0.15 equals e to the a times t. You do natural log of both sides. I'm almost done. And the natural log and e cancel. So I do natural log of 0.15 divided by what I had stored. So I get 15,682.813 years. So then he could determine if it was from that time period or not. Does this make sense? All right, so you guys have your 10.5 homework, so that's due tomorrow. You should have been working on your study guides. So sophomores, even if you're gone, they had a whole period to work on their study guides. So hopefully you guys got a little bit done on that. Your test is on Thursday. Some of you guys are going to be gone on Thursday because you're leaving for spring break early. So you need to let me know and probably take your test tomorrow, right? You don't want to take it when you come back from spring break. That would be miserable. You'd forget everything about logarithms.